Hello everyone. In the last video lecture, I showed you, I was discussing about how to solve linear programming problem using simplex method. I started with a problem but I didn't finish it and told you that I will be continuing that in the next lecture. So in this video lecture, we'll complete the whole problem. We'll complete the whole linear programming problem using this simplex method. So as we saw in the last video lecture that since we were unable to get the optimality condition using initial simplex table, so we had to make the iteration 1 table, and in the iteration 1 table I discussed about how to write the elements for Cj row for basic variable and the x2 row. So I was discussing about filling the elements for s2 row. Now for filling the elements in the row where s2 is there is a formula, that is new value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. Okay, so how this formula works, let's again go to the initial simplex table. So in the initial simplex table, I will be showing you how we will get the new values of the row for S2 in the iteration 1 table. So the formula says new value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. So if I have to find the first element of S2 row, that is below the x1 column, below that x1 variable, in that column if I have to find the element corresponding to that S2 row, then how will I find it? As per the formula, the old value is 8 here. So I'll write 8 in the old value minus corresponding value in the key column. So in corresponding value into the key column is 8 only, into corresponding value in the key row. So for the old value, corresponding value in the key row is 10. I have shown it using the orange lines, divided by key element. Here the key element I have already discussed is 20. So the solution is 8 minus 8 into 10 divided by 20, and it is obtained as 4. So in the iteration 1 table, I will write 4 in the S2 row. So the first element that I got in the S2 row is 4 below this x1 column, below this x1 variable. Now again, if I need to find the second element in the S2 row, which is below this x2 variable, again the same formula I have to use, that is new value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. So in the next slide, I have shown it. For the second element, I have used the turquoise color to make it more convenient for you to understand. So the old value is 8 here minus corresponding key column value. So corresponding key column value is 8 only, into corresponding key row value. For this value, corresponding key row value is 20. 8 into 20 divided by key element. Key element is 20 here. So 8 minus 8 into 20 divided by 20 is 0. So I have put 0 in the second. I have put 0 as the second element of S2 row. So for finding the rest of the elements in the S2 row, same formula I will use. Again, let me take an example for finding the third element in the S2 row. So the old variable, as you can see from this initial simplex table here, the old variable is the 0. Old variable is the 0, and I have used purple color to show the corresponding key column value and corresponding key row value. I have used the purple color. So for 0, the corresponding key column value is 8, and for 0, the corresponding key row value is 1 divided by 20. 20 is the key element. So the solution is 0 minus 8 into 1 divided by 20, which is minus 2 by 5. So I have written minus 2 by 5 as the third element of the S2 row. Minus 2 by 5. So the next fourth element of the S2 row, again the same formula, and I have used the green color to represent the corresponding key row value and corresponding key column value. So the old variable is 1 here. 1 minus corresponding key column value is 8. See, 1 minus 8, the corresponding key row value is 0 into 0 divided by key element, that is 20, divided by 20. So 1 minus 8 into 0 divided by 20 is 1. Similarly, I can find the fifth element of the S2 row using the same formula which I have shown, and moreover for the fifth element I have used blue color to represent the corresponding key column value and corresponding key row value. Again, I am repeating, for filling the elements in the S2 row, I need to use the formula new value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. The old value you will get it from the initial simplex table, which I have already shown in this slide. I have shown the initial simplex table here, and for corresponding key column value and key row value, for your convenience, I have marked lines. That is, for first element I have used orange color to represent the corresponding key column value and corresponding key row value for the old value, and the key element we already know, that is 20. So in this way you can fill all the elements of S2 row. So these are the elements of S2 row: 4, 0, minus 2 by 5, 1 and 32. Next step is to find Zj. Again the same technique that you used in the initial simplex table for finding the Zj, you will be using the same technique here also. So Zj, as I told you, it was summation of Cbi into Aij. So for finding the first element in the Zj row, it will be equal to 16 into 1 by 2 plus 0 into 4, which will come out to be 8. For finding the second element of Zj row, the solution is like 16 into 1 plus 0 into 0, which is equal to 16 only. Similarly, others can be found, like for the third element, it is 16 into 1 by 20 plus 0 into minus 2 by 5, which is 4 by 5. Similarly, the fourth element of the Zj row is 0. Same technique. Now next step is finding the Cj minus Zj row. So till now we have found Zj. Now we will be finding Cj minus Zj. Cj, we have already shown you the very first row, that is the coefficient of objective function, that is 12, 16, 0, 0 minus Zj. So for finding the first element of Cj minus Zj, it will be equal to 12 minus 8, which is equal to 4. For the second element of Cj minus Zj is 16 minus 16, which is equal to 0. What you are doing, just we are subtracting the element of Cj row with that of Zj row. We are subtracting Cj row minus subtracting Cj row and Zj row from Zj row, and we are writing the solution here in the Cj minus Zj row. So the respective elements are getting subtracted. The next step is we need to verify whether, for optimality condition, whether Cj minus Zj elements are 0 or less than 0 or not, that is negative value or 0 or not. If it is not negative value, and if there comes at least even one positive value also, then also we did not reach the optimality condition and we need to proceed further. Otherwise we would have stopped and we would have got the solution if all the values would have been 0 or negative. But since, as we can see, there is at least one positive value, so we did not reach the optimality condition. The next step is we'll find the maximum value of from this Cj minus Zj row. So as we can see from this Cj minus Zj row, the maximum value is 4. So the column corresponding to this 4 will be treated as key column, that is below the x1 variable. The next step is we need to find the ratio. So for ratio, what again the same technique how we used to find the ratio, that is solution divided by the key column elements. Solution divided by the key column elements. So here for finding the first element of the ratio column, it is 6 divided by 1 by 2, which is equal to 12. For second element of ratio column, it is equal to 32 divided by 4, which is equal to 8. So the next step is to find the minimum value from this ratio column, to find the minimum value in this ratio column. Now the minimum value is 8, as it can be seen very clearly that among 12 and 8 is the minimum value, and the row corresponding to 8 will be taken as the key row, which I have encircled using this pencil. Now, so the row which I have encircled is key row, and the variable corresponding to this key row is S2, which is actually the leaving variable, whereas the variable corresponding to the key column, which is x1 here, is the entering variable, and the key element is this overlapping or the intersection of the key row and key column. Here it is 4. The key element is 4. So when we will be making the next iteration table, as I have told you from this table, that S2 is the leaving variable and X1 is the entering variable. So in the next iteration table, I will be substituting S2 with X1. So we will be making the next iteration table 2. Again the same thing. CBI, that is cost of basic variable, CJ, that is all the coefficients of the objective function, BV, that is basic variables. So CJ and BB will remain the same as in the initial simplex table or in the iteration 1 table, that is CJ will be representing all the coefficients of the objective function and BV is representing the basic variables, that is x1, x2, s1, s2. Now below the basic variables in the initial simplex table, I told you that below the basic variables we wrote the slack variables s1 and s2, and then we solved and we found which is the entering variable and which is the leaving variable, and as per that in the iteration 1 table I did accordingly, and I found that in the iteration 1 table it was x2 and s2. Now after solving the iteration 1 table also, I found the entering and leaving variable, and below basic variable in the iteration 2 table, what will be the variables I will be writing? It will be x2 and x1, because here x1 is the entering variable. So x2 and x1 will be the variables that I will be writing in the basic variable column, and the CBI for x2 is the coefficient of x2 in the objective function. So as we can see in the question also, ki the objective function, the coefficient of x2 in the objective function is 16. So I have written 16 corresponding to x2 in the CBI column. And as I've told you, x2 and x1 I'll write in the basic variables column. So I've written x1 here, and corresponding to x1, what is the value in the CBI column? It is the coefficient of the x1 in objective function. So it is 12 here. So I've written 12. Next step, again, what I need to fill the elements in the x2 row. So for filling the elements, same thing what we used to do in the previous iteration 1 table, what we did, old value divided by the key element. So here also we will be doing the same thing, old value divided by the key element. Sorry, in the x1, not x2, it is in the x1. So for filling the elements in the x1 row, it is filled by using the formula, that is old value divided by key element. So here I again want to bring to your notice that when we are going to make iteration tables and when we are filling the elements in the row, then for the already existing basic variable, we will be using the formula that new value is equal to old value minus corresponding key column value into corresponding key row value divided by key element for the existing basic variable column, row. And for the newly entered basic variable, the row elements will be filled using the formula old value divided by key element. So here the newly entered basic variable is x1, and for filling the elements in this row, in the row of x1, it will be filled by old value divided by key element. So from the iteration 1 table, I found the key element to be equal to 4, and old values for x1 row are 4, 0, minus 2 by 5, 1, 32, as can be seen from the iteration 1 table. So what I need to do is old value divided by key element. So 4 is the old value for the first element of x1 row. 4 divided by key element is also 4. So 4 by 4 is 1. Similarly, for the second element of x1 row, the old value is 0 and key element is 4 again. 0 divided by 4 is 0. So 0 is the second element of x1 row in the iteration 2 table. Next element is minus 2 by 5. So minus 2 by 5 is the old value. Minus 2 by 5 is the old value for the third element in the x1 row of iteration 2 table. So the solution is minus 2 by 5 divided by 4, and it is equal to minus 1 by 10. Similarly, the fourth element will be obtained as 1 by 4 and the fifth element is 8. So next step is to fill the elements of the already existed basic variable row, that is x2. So I told you we need to use the same formula that we used in the iteration 1 table also, that is new value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. So for finding the first element of x2 row in the iteration 2 table, I need to go back to the iteration 1 table and use the formula. The formula was for finding the first element in the x2 row of iteration 2 table, the formula was old value. So old value here is 1 by 2 and minus corresponding key column value into corresponding key row value divided by key element. So for this element I have used orange color to represent corresponding key column value and corresponding key row value. So 1 by 2 minus corresponding key column value is 1 by 2 only, and corresponding key row value is 4 divided by key element, and the solution is 1 by 2 minus 1 by 2 into 4 divided by 4 is equal to 0. Similarly 0, so we have put 0 in the as the first element of x2 row. Now for finding the second element of the x2 row, again the same formula, and I have used blue lines to represent corresponding key column value and corresponding key row value. So the old value is 1 minus corresponding key column value, corresponding key column value is 1 by 2 into corresponding key row value is 0 divided by key element is 4. So 1 minus 1 by 2 into 0 divided by 4 is equal to 1. Similarly 1, and I have written 1 as the second element of x2 row. Similarly for finding the third element of x2 row, same formula, that is old value. Here the old value as can be seen from the iteration 1 table is 1 by 20. So 1 by 20 minus, I have used green lines to represent corresponding key column value and corresponding key row value. So they are 1 by 2 into minus 2 by 5 divided by key element, that is equal to 4, and the solution is 1 by 20 minus 1 by 2 into minus 2 by 5 divided by 4, which is equal to 1 by 10. In this way we 1 by 10, so we have written 1 by 10 as the third element of the x2 row. So in this way we can find all the elements of the x2 row using the same formula. Now next step is to find Zj. Again same technique how we used to find the Zj, that is Cbi into Aij. So here also we will using the same technique, that is Zj, first element of Zj, the calculation is 16 into 0 plus 12 into 1 is equal to, which will come out to be 12 only. For the second element of Z0, again the same thing, 16 into 1 plus 12 into 0, which will be 16 only. So for finding an element of Z0, what I need to do is I need to multiply summation of multiplication of Cbi with that corresponding column values of that element. So in this way Zj is obtained as 12, 16, 2 by 5, 1 and 128. Next step is finding Cj minus Zj. Cj is already 12, 16, 0, 0. We know this. Zj we know 12, 16, 2 by 5, 1. So Cj minus Zj, first element is 12 minus 12, which is equal to 0. Then for finding the second element of Cj minus Zj, so second element of Cj is 16, second element of Zj is 16. So 16 minus 16 is 0. For finding the third element of Cj minus Zj, so third element of Cj is 0 and third element of Zj is 2 by 5. So 0 minus 2 by 5 is minus 2 by 5. Similarly, we can find the fourth element also, which is 0 minus 1 is minus 1. As we can see here, all the elements of Cj minus Z0 are either 0 or negative, which is actually satisfying the optimality condition for maximum objective function type linear programming problems. So we have reached the optimality condition and we will stop here and we can find the values of the basic variables. So from here the solution of the basic variables are x1 is equal to 8. So what I need to write, what I need to observe is, after reaching the end, the solution will be x1. So for x1, what is the solution? You need to see the solution column. X1, which is equal to 8, and x2, which is equal to 2, and z, that is objective function, which is equal to 128. So this is the solution for the maximum objective type problem that we discussed using this simplex method. So I will be ending this class here.